Now that we know the process, we are going to look at word problems involving systems of inequalities. And I know that we love word problems, but really part of the reason we don't like word problems is because they're hard sometimes, and trying to figure out how to translate the words into math can be tricky. So we're going to practice and we're going to get better. We're going to be jungle tigers. Remember that video? So example 2A. Solving a problem using systems of inequalities. So here's my situation. We have a pizza parlor, and that pizza parlor charges $1 for each vegetable topping and $2 for each meat. You want to have at least 5 toppings. You like a lot of things on your pizza. But you only have $10. How many of each topping can you get? And before I guess we get started with this, some of you are probably thinking, wait, what about the crust? What about the sauce? All of that stuff. We're just going to go with these prices are your prices for the toppings, and maybe it's an extra like $3 for the crust or something like that. But that doesn't figure into our problem. All right, first thing we have to do is figure out how to write a system of inequalities here. And just kind of looking at our situation, I see we have this information. We want at least 5 toppings, but we only have $10. So I'm going to go off of that. You want at least 5 toppings, but you only have $10 to figure out what our 2 inequalities should be. So I've noticed we're going to have 1 inequality for the number of toppings and 1 inequality for the money that we have. And that pen is dying. We'll use this one instead. All right. And in this blue that I'm using, this is all related to money. I'm going to highlight or underline my other information that's talking about money. So it's $1 for each vegetable and $2 for each meat. So let's put this together. First thing that we have to do is assign what our variables are going to be. Okay. And I'm going to pick X to represent our number of vegetable toppings. And Y to represent the number of meat toppings. So first of all, I want to have at least 5 toppings. At least 5 toppings. Well, if X is my number of vegetable and Y is my number of meat toppings, together, X plus Y, we want to have at least 5. So at least think about what inequality symbol that might represent. It's okay to have 5 toppings. It's okay to have more than that. So greater than or equal to 5. And then our other inequality here, we only have $10. Okay, each vegetable is $1. Each meat is $2. These numbers are going to be our coefficients for these variables. So 1x plus 2y. We only have $10. So let's think, could we spend $10? Yeah. Could we spend more than $10? No, we only have 10. Could we spend less than $10? Sure. So x plus 2y is less than or equal to 10. And you totally could have said that x was your number of meat toppings, y is your number of vegetable toppings. That's okay. All right, let's solve our system of inequalities by graphing. And again, we need to get y by itself. We need to get our inequality into slope-intercept form. Subtract x from both sides here. Y is greater than or equal to 5 minus x. And here, I'm also going to subtract x from both sides. But then I also have to divide by 2. 5 minus 1/2 x. And let's start off by drawing in my axes. And I'm really just going to draw a little bit to the left and a little bit underneath because it doesn't make sense to have a negative number of vegetable toppings. It doesn't make sense to have a negative number of meat toppings. Okay, it's going to be positive for both. My first inequality, y is greater than or equal to 5 minus x. My y-intercept is 5. And my slope is -1. And a solid line because I have that equal to option, shaded above because it's greater than. Right here, my blue inequality, y is less than or equal to 5 minus 1/2 x. 5 is my y-intercept. My slope is -1/2. And solid line because I have the equal to option. Shaded below because it's less than or equal to. All right, so my solution to my system of inequalities here. My solution to my problem, looking for what combinations, how many of each type of topping can I get? My solution is anything in this double shaded region, but not all of these points in here make sense. Like right here, that point doesn't really have any meaning to our problem because we can't have 3.5 vegetable toppings and 2.5 meat. That doesn't make sense. Okay. But in this shaded region, in my double shaded region, let's see, we could have right here, x is my vegetable toppings. I could have 0 vegetable and 5 meat. I could have right here 1 vegetable and 4 meat. Basically, I'm just looking at where do we have ordered pairs on my grid lines here. So right here, I could have 2 veg and 4 meat. I could have 2 veg and 3 meat. Right here, I could have 3 vegetable, 3 meat. 3 vegetable, 2 meat. 4 vegetable, 3 meat. 4 vegetable, 2 meat. 4 vegetable, 1 meat. and then we'll keep going. So 5, 2, 5, 1, 5, 0, 6, 2, 6, 1, 6, 0, 7, 1, 7, 0, 8, 1, 8, 0, 9, 0, or I could have 10 toppings if all of them were vegetable. Doesn't sound like a great pizza to me, but there's the idea. So I'm not going to write all of those out, but hopefully you're kind of starting to get the hang of it. So this can just kind of help us figure out some situations like this where I have inequalities, that several inequalities that all need to be true.